Okay, proof question about divisibility by 3. So before we go into this, let's just think about divisibility by 2 and just extend that to divisibility by 3. Now, if big N is an integer that were divisible by 2, we could write that as big N equals 2k, or 2 little n, 2 times something. And if it's not divisible by 2, we could write it as 2 times something plus 1, i.e. an even number plus 1. With divisibility by 3, if it is divisible by 3, you could write it as 3 times something, 3 little n, say. And if it's not divisible by 3, well, there are 2 cases there, aren't there? There's a multiple of 3 plus 1, or a multiple of 3 plus 2, or equivalently, plus 1 and minus 1, which is what I'm going to use here. So let's just write this down. If big N is not divisible by 3, then big N must be of the form big N equals 3 little n plus 1, or 3 little n minus 1. As I said before, that second one could also be 3 little n plus 2. If that makes more sense to you, just use that. And then we've done the hard bit now, we just have to square, because it tells us to do that here. Square both. So the first case, make it really clear to the examiner, this is a proof, so you set it out nicely. So case 1, I'm going to square that and we get this result, and we have to write it in the form 3 times something plus 1. So I'm just going to do that. And there it is. I don't need to write so little p equals that bracketed expression. That's really obvious. It's 3 times something plus 1. As long as I've got a good conclusion at the end, we're fine. Okay, just go through the same motions for case 2. And finish off by putting that also in the form 3 times something plus 1. And I've not left enough space for a conclusion. But there's my conclusion, which would go underneath both of these cases. Just to finish off, remember it's a proof, so what have you found? Well, in both cases, n squared is of the form 3 times a thing plus 1. The thing they've used in the problem is p. So that's that.